Okay, we're going to start Unit 3 test review homework help off with a joke / riddle. More of a joke. Why do seagulls fly over the sea? Because if they flew over the bay, they would be called bagels. Hey! Okay, you're welcome. You can use that one to impress all of your friends. So, Unit 3 test review is so much fun because I go through all of them. So without further ado, off we go. And I'm going to remember to write down the answers as I go so I don't have to do it later. All right, so number 1 and number 2, it says solve by factoring. So the first one is x squared plus 9x minus 10 equals 0. Solve by factoring. Hold on. Let's see if I can get rid of the glare without making my shadows look obnoxious. That might be okay. Bring you in a little bit. Okay. So, by factoring. So you have to think of factors of -10 that add up to 9. Okay? So factors of -10. It's helpful that it's -10 because you know one of them has to be negative. So factors of 10, here we go. 5 and -2. Okay? They multiply together to get -10, but they also need to add up to 9. Do they add up to 9? No. They add up to 3. Okay, so that's not it. What if I switch it -5 and +2? They multiply together to get -10, but do they add up to 9? Well, let's see. -5 plus 2 is -3. No. What about -1 and 10? If you multiply those two numbers together, you get -10. If you add them up, you get 9. Aha! So those are our two factors. See, my shadow is just, anyways. So it's x minus 1 and x plus 10. You are not finished with this problem. You found the factors, so you wrote it in factored form, but we need to solve. We need to solve. Okay. So once you have two factors, what you can do is put them equal to 0. So x minus 1 equals 0 and x plus 10 equals 0. Because if this is 0, 0 times x minus 1 is 0. If this is 0, 0 times this is 0, right? 0 times anything is just 0. So as long as one of these is equal to 0, as long as one of these is equal to 0, then the whole thing will be equal to 0, okay? Which is what we're trying to find out. So go ahead and solve for x. And what are your two answers? See, now it's too dark. I can't win. Just try and avoid some glares. Okay. So your answers are x equals 1 and x equals -10. Okay, so that's how you solve by factoring. So those are your two answers. So you can leave it like that, or you can write x equals 1 and -10. If you were to graph this equation, it would cross your x-axis at 1 and -10. It would cross your x-axis at 1 and -10. These are your x-intercepts. Okay? Okay. We'll do the next one. Okay, this is number 2, which I wrote right on its layer. Of course I did. Number 2, r squared plus 12r plus 32 equals 0. So you still have to solve by factoring. Those are the instructions. Okay? So please, hold on. Please try these by yourself. And then if you get stuck, you should be watching me, right? Or if you're like, Ms. Bailey, I have no idea, then we just did one together. So pause me and try and find the factors yourself, okay? Because you're going to have to do it by yourself on Monday. Okay. Hopefully you paused me and tried. So we have to find factors of 32 that add up to 12. So it's a positive number, so they're either, and this is a positive number, so your factors are going to be positive. I mean, the first one I think of is 8 and 4. Okay, but you can go through all of them. You can go 2 and 16. If you multiply those together, 2 times 16 is 32. 2 plus 16 is 18, so that's not it. Okay? So if you do 8 and 4, 8 times 4 is 32. And if you add 8 plus 4, do you get 12? 8 plus 4, yeah, is 12. So these are your factors. R plus 8, R plus 4 equals 0. Once again, you're not done. You have to solve. What value of R will make this equal to 0? What value of R will make this equal to 0? Well, if this is 0, then everything will be 0. So what number plus 8 is 0? Remember, you can set an equal to it. So R plus 8 equals 0. And R plus 4. Okay, and then solve for R. So I would subtract 8. So R would equal -8. And R would also equal -4. So those are your intercepts. If you graph these, if you graph this, your x-intercept will be -8 and -4. -8 and, oh boy, -4. Once again, that is how you solve by factoring. If you stop here, I'm not going to give you credit. You have to solve it. All right. There, I kind of wrote below the glare. Okay, so number 3, it says solve by completing the square. Oh, I'm not writing down the answers. Hold on. Okay, sorry. We're good. Oh, it should say equals 0. Solve by completing the square. Completing the square. I like to move my C term over. X squared plus 12x. So I'm going to subtract 32 from both sides. Okay, so those are going to cancel each other out. So x squared plus 12x equals -32. All right, Now you're going to complete the square on this side. So x squared plus 12x plus something equals negative 32 plus whatever this number is, because whatever I do to one side of my equation, I must do to the other side. Okay. Completing the square. Please let me know if you want more practice on this. I'm happy to send you more practice problems if you don't feel like flipping through your past homeworks. To complete the square, it is b over 2 squared. All right, that's your little formula. B over 2 squared to complete the square. Goodness. So, B is 12. So you take 12 over 2, square it. All right, go ahead and do that. Okay, so you get 12 divided by 2 is 6. 6 squared. So you get 6 squared, which is 6 times 6, which is 36. I say which is a lot. This is 6 squared, and that equals, whatever, 36. So make sure you add it on to both sides. I'm going to erase this because it's in my way. Okay, now you're going to write this side in its factored form. Since it is a perfect square, and we know it is because we just completed it, which made it a perfect square, we just made it a perfect square, just take half of the middle term. Half of 12, which is 6, equals 4. Also, you could take the time to factor this. Think of 2 factors of 36 that add up to 12. It would be 6 and 6. All right, so that's why it's x plus 6 squared. Remember, you're solving for x. So I want to get rid of this squared. How do I do that? Think about it. How do I get rid of the squared? You take the square root of both sides. Okay. Where do I want to put it? Oh. The square root and the squared cancel each other out. So you're left with x plus 6, and then the square root of 4, positive, negative 2. And then you're solving for x, so you're still not quite done. Last step, I'm going to subtract 6 from both sides. So I get x equals negative 6 plus 2 and negative 6 minus 2. So you have your two answers. Negative 6 plus 2, negative 4. And then negative 6 minus 2 is negative 8. So those are your two answers. That's how you solve by completing the square. X equals negative 4 and negative 8. Okay? Oh, you need to zoom in a little bit. All right, come here. Okay. Oh, sorry. Let me pause you. Okie dokie. This is number 4. So you still have to solve by completing the square. Remember, you must know how to do all 3 ways for the test. So here we go. No, wait. You tried it by yourself, right? Because we just did one together. So make sure you're trying these by yourself. Then if you get stuck, look back at our first one that we did. Okay, and then if you're still stuck, here I am. So I'm going to move c over to the other side. X squared plus 10x plus going to be negative 8. Then I'm going to complete the square on this side. Okay. So look back at the formula that we used on number 3 to complete the square. What number do you get here by completing the square? Pause me, please pause me and try it by yourself. So remember, our formula is h equals negative b over 2a. All right. So substitute into it. So what is b? B is 10. Negative 10 over, I'm sorry, I'm doing the wrong thing. Where's my brain at? Not on this problem. To complete the square, it's b over 2 squared. There we go. Like, that doesn't seem right, because it's not. Sorry, this is your little formula, b over 2 squared. So b is 10. All right, 10 over 2 squared. What is 10 over 2 squared? Ten divided by 2 is 5, so you get 5 squared. And 5 squared is 25. Make sure you add it to both sides. Okay, factor this side. So you can take half of your middle term. But if you don't trust me, or you don't remember that, you can say, okay, I need 2 factors of 25 that add up to 10. 2 factors of 25 that add up to 10. That would be 5. You get x plus 5 squared equals, yeah, 25 minus 8. Be careful with your signs. 25 minus 8 is 30. 37? Really? Is that what I wanted that to be? Oh no. Ooh, 17. Hello. That's still not what I thought I planned for that to be. Okay, well. Okay. Carry on, anyways. So now, you have to take the square root of both sides. Okie dokie. These cancel each other out. So on this side, you're left with, and then if this was 17 is a sorry, something popped up on my screen. We're good. 17 is a prime number. If it was not a prime number, you would have to simplify the radical. But it is. The only numbers that multiply together to get 17 are 1 and 17, so you're good. Just leave it as plus or minus the square root of 17. And then keep solving for x. We want x by itself. So we're going to subtract 5. So we get x equals -5 plus or minus the square root of 17. And you can leave it like that. You do not have to make this, because the square root of 17 is going to be what? 4 point, I don't know, 4 point something. 4 point, a decimal that goes on forever. So you don't need to turn it into a decimal, just leave it like this. -5 plus or minus the square root of 17. Okay, that's number 4. Okay. Number 5 says, solve with the quadratic equation. Oh, it looks so small. It really so small. It doesn't look so small on here. Anyways, so quadratic equation. -b plus or minus b squared minus 4ac all over 2a. Oh, maybe because you're a little zoomed out. Let's bring you in a little bit more. Okay. So, make sure you're trying this before you watch me, okay? So I'm going to identify A, B, C, 1, 2, 3. No, it's, well, A is 1, B is -4, and C is 5. Now that you know these, you can substitute into your quadratic equation and solve it. Okay, make sure you pause me and try that by yourself. Try it. Okay, so -b. B is already -4. So negative and negative, that makes it +4. All right, let's do our discriminant. So b squared, which is -4 squared. -4 squared is 16 minus 4 times a, which is 1, and c, which is 5. All over 2 times a. A is 1, so it's all over 2. Oh, I just got hungry. Oh, we don't have any food here. Okay, keep going. 4 plus or minus. Here we go. Oh, well, I'll leave 16 there. 16. And then -4 times 1 times 5. -4 times 1 is -4 times 5 is -20. All over 2. Do one more right here. 4 plus or minus 16 minus 20. -4 all over 2. Okay. Here is where your use of I comes into play. You have a negative under your radical. Your discriminant is -4. You have a negative under your radical. That means your roots are going to be imaginary. Okay? So, since I'm already over here, let's break apart the square root of -4. So the square root of -4 is equal to the square root of 4 times the square root of -1. Okay, and remember what we learned, Wednesday, probably. I is equal to, can we see that? Yes. The square root of -1. Thanks to Euler, all right? So, the square root of 4, we're going to do 2. And then the square root of -1 is I. So the square root of -4 is equivalent to 2i. These are equal to each other. All right? You're not done yet. You're not done yet. Come here. 4 plus or minus. So this is now 2i, right? We just did that. All over 2. 4 plus or minus. This became 2i all over 2. Last step is to divide. 4 divided by 2 is 2, plus or minus 2i divided by 2 is just 1i, and you don't need to write the 1, you can just write I. So 2 plus or minus I, and that is your final answer. So if I were to graph this, it would never cross the x-axis. That's why the roots are imaginary. If I graphed it, they would never cross the x-axis. Okay, so that was number 5. Okay, number 6. So you're still solving with the quadratic equation. Did you try this one? Oop, 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 come there. There we go. Did you try this one by yourself first? Try it by yourself first, okay? It doesn't, well, it helps a little bit. It helps you more if you try it by yourself. Don't just copy me, all right? Pause me as I go along and try it by yourself. So the first thing you're going to do is identify A, B, and C. Here's our equation. 3x squared plus 14x minus 5. So A is 3, B is 14, and C is -5. Now that you have these terms, you're going to substitute them into your quadratic equation and solve. Actually, I don't need that. Okay. Okay. So negative b. B is 14. So that's -14. Your discriminant, b squared minus 4ac. 14 squared, oh geez. I'm not going to come up with it off the top of my head. Hold on. This is when I need Alden or Sammy so they can just tell me the answer. 196. B squared is 196 minus 4 times 3, times A, which is 3, times C. All right. Oh, sorry. All over 2 times 3, which is 6. Because A is 3. Woo! -14 plus or minus. Let's deal with this stuff. I have 196. Here we go. Be careful with your signs, please. If you get the wrong sign here, it's going to mess up the rest of your problem. So -4 times 3 is -12. -12 times -5 is +60. Okay? That's what I mean. Be careful. If you want -4 times -3 is -12 times -5. So that gives you a +60. All over 6. Okay? I think I can fit one more down here. -14 plus or minus. So then just add those together. Sorry. 196 plus 6. Okay, equals 256. All over 6. Okay. Things to notice. You have a positive number under your radical. That means you're going to have real roots, real solutions, real roots, okay? They will not be imaginary, they will be real. So let's think about 256. Is 256 a perfect square? If you don't know off the top of your head, oh geez, which it is a perfect square, I'm pretty sure. Oh, too much. I think it's 16 times 16. Let me check. Yes. So it is a perfect square, but if you didn't know that, you could factor it. It sounds fairly awful. You could factor it. You could find the prime factors of 256. All right, but it is a perfect square. It is 16. So let's go up here. Maybe, yes. Negative 14 plus or minus. So the square root of 256 is 16. Okay, positive or negative 16 all over 6. All right, and then you just can reduce it. So if you want, if it helps you, you can rewrite it negative 14 over 6 plus or minus 16 over 6. If it helps you to write it out as two different fractions, please do so. Doesn't bother me in the slightest. All right, and then you're going to reduce. So I can divide both of these by 2. So that gives me negative 7 over 2 plus or minus. I can divide both of these by 2. Oh, sorry, that's a 3. 6 divided by 2 is 3. Divide both of these by 2, which is 8 over 3. Okay, we're not done, but we're almost done. Let me move you this way a little bit more. Okay. So really you have negative 7 over 3 plus 8/3 and negative 7 over 3 minus 8/3. All right, so this is negative 7 plus 8, negative 7/3 plus 8/3, 1/3. And this one, your remember, your denominators are the same, so you're just dealing with the numerators. So negative 7 plus 8 is 1. Negative 7 minus 8 is negative 15 over 3. Which is negative 5. Woo! We did it. So your answers are x equals 1/3 and negative 5. So both of your roots are real, and they are both rational. There are 2 of them. There you go. Okay. 7 through 9. It says, find how many roots and classify. Are they complex or real? If they're real, are they rational or irrational? So this is where we're going to use our discriminant. Oh, this is from the last problem. Hold on. Let's erase that. Our discriminant, which is b squared minus 4ac. I'll put it right here. B squared minus 4ac. All right, when it asks you to find how many roots and classify them, you can use the discriminant. All right, here we go. So, we don't really need this right now either. Write down A, B, and C. A is 1, B is 9, C is negative 2. Okay, now that you know these values, you're going to substitute into your discriminant. So b squared, that's 9 squared, so that's 81, minus 4 times a, which is 1, times c, which is negative 2. Okay, multiply these three together. Negative 4 times 1 is negative 4 times negative 2. Negative 4 times negative 2, positive 8. Jeez. So you get 81 plus 8, which is 89. Okay. So, as soon as you knew you were going to get a positive number as your discriminant, you knew that your solutions were real. Okay? Now, you have to answer, are they going to be rational or irrational? So the question is then, is 89 a perfect square or not? If 89 is a perfect square, then they are rational. If it's not, then they are irrational. And 89 is not a perfect square, so they are irrational. I think you also have to say how many. Do you have to say how many? Yes. And how many are there going to be? There are going to be 2. Two real irrational roots. Remember, the only time there's 1 is if you have is when your discriminant is equal to 0. If your discriminant is equal to 0, then there is 1 repeated root. Okay, that's number 7. Oh, sorry, this is no longer number 7. This is number 8. Okay, so same thing. You're classifying the roots and finding out how many of them there are. So you're going to use the discriminant, which is b squared minus 4ac. So go ahead and find out your values for a, b, and c. A is 1, b is negative 18, and c is 81. Now that you know that, substitute them in and solve for your discriminant to figure out if you're going to have real or complex roots. Okay, so, ay caramba. So b squared is negative 18 squared, which is 324. I used a calculator. There's no, I don't know why you would have that memorized. And then minus 4 times a times c. All right, and then you have negative 4 times 1 is negative 4. And then you have 81 times negative 4. Oh, okay. Which is 324 minus 324. Does that make sense? Right, so 324 minus 324, 0. So if your discriminant is equal to 0, what does that mean? It means real. 0 is a perfect square, so it's rational. Okay, and then how many are there? 1. 1 real rational root. When your discriminant is 0, that means there is only one real rational root. All right. All right, number 9. So, how many roots n classify? Oh, that was from last problem. So go ahead and identify A, B, and C from your equation. A is 3, B is 8, C is -1. Okay, now you're going to use these and you're going to substitute them into your discriminant. So make sure you pause me and try it yourself. So B squared, so 8 squared is 64, minus 4 times A, which is 3, times C, which is -1. And then you're just reducing it. Multiply these 3 together. -4 times 3 is -12 times -1. Huh. 3x squared plus 8x minus 1. I don't know, whatever. Okay, so you get 64, and then that's plus 12. 64 plus 12, so you already know it's going to be positive 76. I don't think that's the problem I meant to put on there, but oh well. So then 76, it's positive, which means it's going to be real. So then is it rational or irrational? Is it a perfect square or not? If you can't, think about the perfect squares close to it. So like 9 times 9 is 81. 8 times 8 is 64. So this is not a perfect square. So it is irrational. Huh. Oh well. And then how many are there? How many roots are there? 2. There are 2 real irrational roots. Okay, your directions for 10 through 13 are simplify. So number 10 is the square root of -5 times the square root of -20. You don't need to use I. Remember radical rules. I can multiply these together. -5 times -20 gives me the square root of -5 times, oh, I'm right on the, hold on. Right on the glare. Yeah. There. -5 times -20 is positive 100. Right? I multiplied these two together. Remember, if you're multiplying radicals, okay, let me write the rule. Where can I write it? Right here. So if I have the square root of A times the square root of B, that is equal to the square root of AB. That's one of our radical rules from last chapter. Okay, so you get the square root of 100, so your answer is 10, positive or negative 10. And that's it. That's all. That's all you gotta do. All right, number 11, 6i squared. Simplify. So you're going to square both things inside. So that gives me 6. Oh, am I on the glare? Not quite. 6 squared, and it gives me I squared. 6 squared is 36, and I squared, remember that I squared equals -1. So if you just leave it 36I squared, you're not all the way simplified. You have to substitute -1 in for I squared. Substitute -1 in for I squared, so you get -36. And that is your answer. Okay. Here is number 12. So we did examples of this type of problem in class today. I think both classes did 2 examples of this type of problem. Five plus 3i minus 3 plus I. So you have 5 plus 3i, and then you're subtracting this. So this becomes -3 and -I. I'm right on the glare. I thought I went low enough. Hold on. My bad. Better? Yes. 5 plus 3i minus 3 minus I. Minus 3 minus I. Okay? If you want to rewrite it so your like terms are next to each other, you can. So that would be 5 minus 3 plus 3i minus I. All right, get your like terms together if you want to, and then combine your like terms. 5 minus 3 is 2. 3i minus I is 2i. And you do not reduce it any further. You leave it like that. Okay. Okay, here's number 13. Number 13. Simplify. So don't let like how a problem looks freak you out. Remember, one thing at a time. Okay, so I want you to start out by simplifying your radicals. If these were prime numbers, you would not have to do anything. But these are not prime. So let's start with 18. So you're going to do the prime factors of 18. Okay, so let's do, you can do 6 and 3. I'm going to do 9 and 2. 2 is prime, 9 is not. Keep going. 9 is 3 times 3. Okay, so I'm going to rewrite my 3. And I just did the square root of 18. Oh. So it's 3, 3, 2. Okay. Square root of 18 is the same thing as 3 times 2. You're doing square roots, so look for groups of 2. I have 2 3s, pull one out. So the square root of 18 is the same thing as 3 times the square root of 2 plus 3. All right, and now you have to do the same thing with 72. So, factors of 72. Let's do 9 and 8. Okay. Keep factoring until you get prime numbers. 3, 3. 8 is 4 and 2. All right, so you can rewrite the square root of 72 as, see, I have 3 2s and 2 3s. So 2, 2, 2, 3, 3. Then it's the square root, so you're looking for groups of 2. 1, 2. I'm going to pull out a 2. And then there's one more 2, but I have to leave that one there, and then I have 2 3s. So I can pull out a 3. So I pulled out a 2 and a 3, so I have 2 times 3 times the square root of 2, which is 6, square root of 2. And then minus 2. Oh man, I thought I avoided the glare. So combine your like terms. 3 minus 2 is 1. And then 3 square root 2 plus 6 square root 2. You can add those together. 6 plus 3 is 9. All right, and that would be how you leave your answer. You can leave it like that. You do not need to convert it into a decimal. All right, we're getting there, guys. We're getting there. Number 14, find the minimum of the following equations. So they give you this one in factored form. So the way I recommend doing it, I would go ahead, remember, you're trying to find the minimum, which means find the vertex and whatever the y value is, whatever k is, that's going to be your minimum. So find the vertex and then whatever k is, that's your minimum. So I'm going to start out by finding the x-intercepts. All right, so what values of x would make this equal to 0? All right, it's going to be x equals 6 and 12. Positive 6 would make this 0, which would make everything 0, and 12 would make this 0, which would make everything 0. All right, because 0 multiplied by anything is 0. All right, then the vertex is halfway in between your x-intercepts. It's halfway in between. So halfway between 6 and 12. You can write them all out like a number line and then find the middle, or 6 plus 12 divided by 2. 18 divided by 2 is 9. So you have the first part of your vertex. You have h. So to find k, you substitute 9 back into your original equation. So go ahead and do that. Please pause me and try these things by yourself. Oh, sorry. And, oh, no, it's right. All right, so I substituted in 9 for x. 9 minus 6 is 3 times 9 minus 12, which is negative 3. So you get negative 9. So this is your vertex, and your minimum value is negative 9. All right? Okay, number 15. Same thing. Find the minimum value. So find the vertex, whatever k is, that's your minimum. So this time they give you standard form. 2 ways you can do it. Oh, there we go. 2 ways you can do it. You could complete the square to turn it into vertex form, or you can use this formula, h equals negative b over 2a. Your vertex is hk. So if you use this formula, you can find h, and then whatever h is, substitute it in for x to find k. All right? Go ahead and try that. Make sure you pause me, please, and try it. Okay. Hopefully you paused and tried. Here we go. H equals negative b. So b is negative 12. So that makes it a positive 12. Because you have a negative and a negative. Positive 12 over 2 times a. A is 1. Equals 12 over 2, which is equal to 6. So that's half of your vertex. So you know h. Okay, so now find k. All right, so I'm going to substitute. So I'm going to substitute 6 in for x and solve. Right on the glare, of course. So 6 squared is 36. Negative 12 times 6 is going to be negative, 12 times 6. Yeah, I don't know. I can't do math. Wait, I do know. 72. Minus 72 plus 18. Let me make sure. Yeah. And then keep solving it. So 36 minus 72 plus 18. You should get, hopefully, negative 18. Right? So ta-da, that is k. That is your y value. So that's your vertex. Therefore, your minimum is negative 18. Okay. I think I said I'd do it both ways. I just remembered that. I'll do it both ways. So if you want to do it by completing the square, I'll leave it all on the white. Wait, my glare is going to be right there. This time I'm going to complete the square and I'm going to do it all on this side. All right. So it's going to be x squared minus 12x. This is where you put this in parentheses and put c on the outside for now. If you want to do it the other way, do it the other way. But I think I said I'd do it both. So, and then you're going to complete the square inside the parentheses. And whatever you add on to here, you must subtract because we're working on one side of the equation. Okay, we're working on one side of the equation, so you have to subtract it out. So complete the square. So you do half of negative 12, which is negative 6 squared. 36. Go ahead and factor this. We just made it a perfect square, so you can just take half of your middle term and square it. Half of negative 12 is negative 6. Half of negative 12 is negative 6. And then you have 18 minus 36, negative 18. Now you have it in vertex form. Throw back to chapter 2. You have it in vertex form. So you can pull out your vertex. Oops. Your vertex is the opposite of what's inside, and then negative 18. So you get the same thing. So you can do it either way, whichever way you prefer. So then your minimum, once again, would be negative 18. All right. Okay. 15. Find the minimum value. So you are finding the vertex, and then whatever k is, whatever the y value of your vertex, that's your minimum. Whatever k is, that's your minimum. Well, this one's nice, because I give it to you in vertex form, so just pull out the vertex. Remember, vertex form, if you don't remember, that's vertex form. X minus h squared, a, which we don't have an a, so a is just 1, x minus h squared plus k. And your vertex is hk. So you're going to pull out the vertex. So h is, it's the opposite of whatever you see inside, so it's 1, and then negative 18. So once again, your minimum is negative 18. Okay, here are the last ones. It says classify the following numbers: real, complex. Remember, complex means imaginary, you're dealing with an I. Rational, irrational, integer, and whole. List all that apply. So this is like our Jamboard activity that we did. Okay, list all that apply. Here we go. 17 is the square root of negative 17. So you're taking the square root of a negative number. That's automatically complex. Square root of a negative number. Complex. 18. 5 over 2. So all numbers are either real or complex. So this is real. Then is it rational or irrational? Rational. Okay, if you can write it as a fraction, it's rational. If you wrote it as a decimal, it would also not go on forever, right? And then, is it, then we get, is it an integer? No, it's not. I thought I was getting something. Oh no, that's it. So it's not an integer, which means it's not a whole number. Okay. Pi. Pi is it real or complex? Real. Is pi rational or irrational? Irrational. Irrational. This decimal goes on forever without repeating. So it is irrational. Goes on, the decimal goes on forever without repeating. 20. Negative 101. Is it real or complex? Real. Is it rational or irrational? Rational. Right? Is it an integer? Yes. Is it a whole number? No, because it's negative. Whole numbers are only 0 and positive. So no, it is not a whole number. 21. 8 over 2. If I were you, I would reduce it first. What is 8 over 2? It's 4. All right, so then 4, is it real or complex? Real. Is 4 rational or irrational? Rational. Is 4 an integer? Yes. And is 4 a whole number? Yeah. Okay, let me move 22 down just a little bit. Okay, 22, the square root of 9. Is the square root of 9, well, what is the square root of 9? It's going to be positive or negative 3. Let me clarify this in a second. So, it is real. It's a perfect square, so it's rational. Whether your answer is 3 or negative 3, is it an integer? Yes. Integers are positive and negative whole numbers. All right, now, is it, oh, right on a glare. Oh well. Is it whole? If your answer is positive 3, then yes. So really, I'll accept either one. Because negative 3 is not. Negative 3 is not a whole number. But if you write whole, then I won't count it incorrect because 3 is a whole number. So either one is fine. You can either stop there, or you can write whole and I will mark it incorrect. Okay? Because positive 3 is whole, negative 3 is not. All right. Oh my goodness. We did it. Thank goodness. Email me or text. Oh, I went wrong way. Email me or text me with questions, please. Please, please, please.